So students, today in our second sem mathematics class, I am going to start Taylor series and Maclaurin series. And myself Sri Sevtu Talukdar, faculty, Department of Mathematics, Bikali College, Chulthara. And today's topic is nothing but Taylor's formula with remainder. And we are going to discuss 5 points here. Number 1, Taylor remainder for all Taylor series. And definition of Taylor's formula. 3, Maclaurin and Taylor series together. Fourthly, Maclaurin series for the function, especially fx equal to the exponential function fx, and another function f of x is the trigonometric function sin x. And finally, we have to discuss Taylor's series for the functions fx equal to 1 by x. An example is a rational function fx equal to 1 by x about to point x equal to 1. So, at first, we are to discuss the Taylor polynomial for the rational function 1 by x about x equal to 1, and we express it in sigma notation. How we can express in sigma notation? So, you have to solve in this way. You have to follow the process of solution of this type of problems like this. So, at first, you assume that the given function, polynomial function fx equal to 1 by x, and the value of this function f and its first k derivatives. That means you have to take the derivative of the function f as first derivative, after that second derivative, after that fourth derivative, fifth derivative, and k time derivative of the function we are given. So at x equal to 0, or you can follow this, whenever you take the function fx equal to 1 by x, then f to the power 1 equal to 1. At the point x equal to 1. And its first derivative, the first derivative of f of x equal to 1 by x is nothing but you take the derivative. That means the dx of 1 by x is nothing but, what is 1 by x? X to the power minus 1. So its first derivative will be minus 1 divided by x squared. And at the point x equal to 1, the first derivative is minus 1 by 1 square equal to minus 1. Similarly, second derivative of f at the point x, you again take the derivative of f dash x. The dx of f dash x is nothing but 2 divided by x cube. And at the point x equal to 1, we are going to find the polynomial about x equal to 1. So f double dash 1 is nothing but 2. And the number 2 can be expressed in factorial notation. 2 factorial means 2 into 1. And we have so many times of derivative, third derivative, fourth derivative, up to kth derivative. Last derivative we can write as f to the power kx, means k times derivative of the function f, x equal to 1 by x. So f to the power kx is nothing but following all these derivatives, factorial k divided by x to the power x plus 1. And at the point x equal to 1, k times of derivative of the function f is f to the power k1 is equal to minus 1 to the power k into factorial k. After that, it will be convenient to have a notation for the error in the approximation of the function, polynomial function f. And approximately that function is supposed to be p and x, suffix n Polynomial is P. So P and n times polynomial of the function about x. Accordingly, we will let the remainder term Rn, capital R, suffix n, Rn x, which denote the difference between the polynomial function f and its nth Taylor polynomial. And that means we can write Rn x, remainder term of the Taylor series, is the difference fx minus Pnx. Fx minus Pnx is nothing but the nth Taylor polynomial. And after that, in our second step, we have to write fx minus, that is Pnx. Nth Taylor polynomial is nothing but sum of k goes from 0 to n, f to the power k divided by factorial k, x naught into x minus x naught whole thing to the power k. And this can be written as, we can write it in this way, f of x is equal to Pnx plus Rnx. Nth Taylor polynomial logot, but with nth Taylor polynomial, we have to add the remainder terms. And this is nothing but sum of k goes from 0 to n. We have to assume the value of k from 0, 1, 2, 3 up to n into summation k goes from 0 to n f to the power k divided by k factorial x naught at the point x naught into x minus x naught whole thing to the power k plus the remainder term Rnx.